This lesson follows the 4.1 Lesson 1 experimentation that you just finished with the air bottle and the hot and cold water dunking of that. So therefore you need to be using your guided notes from the previous lesson to do the second half, which is our discussion right now. Expansion and contraction, some new vocabulary words. Not compression and expansion, but expansion and contraction, a different word there. How can you explain what happened to a balloon when a bottle and balloon system was placed in hot water? Give it a try. Expand or expansion. First off, please excuse my Chiefs hat. I just got back from the Panthers-Chiefs game. That's what's so strange about this year. It's actually November 8th right now as I'm recording this. And you guys are in the next week. So, yeah, we just beat the Panthers. It was a beautiful day. I think one of the last nice, beautiful days. Let's go to what happened when that balloon expanded. Why did it do that in the hot water? When a volume of gas gets hot, its volume increases. The process of increasing volume is called expansion. Air, like all gases, expands when it gets hot. This means that the empty space between particles increases. So if I think of my fist as two particles of gas, when they expand, all that's happening is the space between them increases. This is empty space between my fists. And when gas expands, empty space expands too, or the volume expands. That doesn't mean I have more fists. I do not have more gas. I just have more space between the gas. That's the definition of expansion, more space between. Contract, contraction. How can you explain what happened to a capped bottle with warm air in it when you put it into cold water? Give it a try. So in the same way with my two air particles as I had before, if these are gas particles and they're moving around erratically inside my bottle, and they were warm, so they were expanded, or there was a lot of space in between, what happens when then I plunge the bottle of air into cold water? Well, the balloon deflated, the bottle kind of collapsed in upon itself, the bubble of soap may have come down inside the bottle, and all of that is because my gas particles have just moved closer together. They have moved closer together, so there's less space. I did not lose gas particles. I lost space between them. My volume decreased. Kinetic energy is the energy of motion. Kinetic means motion. So the gas particles, they're always in motion and they're moving at super rapid speeds. So they're always moving around each other and they're hitting each other as they move around. Some particles move slow and some move super fast and hit hard. The speed at which particle moves is called its kinetic energy. So speed equals kinetic energy. So if I have a slow moving particle, the kinetic energy is low or slow. If I have fast moving particles, the kinetic energy is fast. And so there I just did my dance. So time for some collaboration. Get with someone near you and make sure this person has began their investigation and have these quick discussions. What caused the tube to blow bubbles when it was underwater? Was it the hot bath of water or the cold bath of water that caused the flow of air to come out of the tube into the bubble solution? And in the same way, what caused water to go up the tube when it was underwater? Was it the hot or the cold? What caused the plastic bottle to crush upon itself when you didn't apply any force when it was placed in cold water? Think about contraction, particles moving closer together, and expansion, particles moving farther apart, when you write down your answers to these questions. You can find the definition for these words, contract, contraction, and kinetic energy, in this presentation, or you can go to your purple book into the back where there is the glossary. Find the definition and draw a picture of what contraction, and kinetic energy means to you. Lastly, I have a challenge for you. Look around your world for examples of an expansion and contraction. In order for you to find examples, look where there are temperature changes, often rapid temperature changes, and look at materials around the areas where there are temperature changes. Come and tell your teacher what you found.